and welcome back to the Python Basics tutorial. In the previous video, I covered control flow with if statements, for loops, and while loops. In this video, I'll be covering functions, how they're created, the many types of functions, and the arguments that you can pass through them. So we start here with the definition of an empty function. A function will always begin with the keyword def, D-E-F, and you can give it a name, similar to a variable. It also has the declarations and can be used with snake case, camel case, or Pascal case, though the standard is using camel case for functions. So here you can see we say def, we have the name of our function, and then we have here a set of parentheses and then a colon right after. And what this basically does is, at this point, I can say my empty function. So the way we would call this function within our code is by saying just the name without def, and then whatever is inside the definition will occur once we run this statement here on line 8. So let's take a look. Here we define our function, and then what we call calling a function is what we do on line 14. Here we see my first function, and inside my first function we have a print statement that says hello world. So when we run this, my first function is going to check the definition of my first function, and it's going to say, okay, he wants me to run my hello world. And indeed, my hello world is printed to the console. But functions can also have a return statement. So in here what we say is definition my first function, I want to return 2 plus 3. What this basically means is that we can actually print the call of my first function because we know it will return a value of 2 plus 3, which in this case is 5. So the important thing to know about the return statement is that as soon as you return, then the function stops operating. It will immediately shut down as soon as the return statement is printed, and you can even see here it says the code is unreachable because of the return statement here. And if I print it out, you'll see that it says before the return statement rather than after the return statement. Next we'll talk about local and global variables. So global variables are defined outside of a function. They're often initialized here, and they can be any type of variable, any data type. They can be booleans, tuples, strings, and here inside of my definition, my test function, here I have a print statement that says Python is my global variable. And once I include my global variable, Python will go and will search for all the global variables, and it will see and say, hey, my global variable is equal to cool. So then it will take this my global variable and insert the value of cool into this statement. So when we run this, we should see Python is cool. Now, local variables are defined inside of a function. So instead of having my global variable initialized outside of my definition of the test function, here my local variable is defined within cool. So when we have my Python plus my local variable, Python will search first all global variables, and then it will go inside of the function, and it'll say, hey, my local variable is equal to cool, and then it will take cool and place it in here in my local variable. So when we run this, we should also see Python is cool. So here we have global and local variables. We have definition my test function. My local variable is fantastic. And then we have a print statement. Python is my local variable from function. Python is my local variable from function. And then we have my global variable is awesome. So both of these statements were run from inside the definition, from inside the function. And then one was taken from locally, one was taken from globally. So when we run this, you can see Python is awesome from function, Python is fantastic from function. So from within a function, Python has no trouble getting both local variables and global variables. But the interesting thing to point out is when we try to say Python is my local variable. So when we define variables within a function, we can only receive the values of those variables also from within that function or from a return statement. So here we can say return my local variable, and then here we can say Python is my test function. And in this statement, we will be able to receive the word fantastic. Here you can see that is indeed true. However, just this statement will not work. You can see it's also even giving me an error because it says my local variable is not defined. Because Python does not search within definitions from outside of a definition. So here, Python will search all the global variables, but it cannot search any local variables within any other functions. Next we have arguments. So there are two types of arguments, and well, first I should explain, what is an argument? An argument is a value that you insert into a function. So here I have definition, my second function, and inside the parentheses I have person name. Arguments are also sometimes called parameters. So here you can see it saying that it is a parameter. And when we print my person name, when we now try to call my second function, we have to give a value when we call it. That is basically a requirement. If we try to call without including this argument, you can see it gives us an error, missing one required positional argument, person name. So we basically give this definition a rule. We say, okay, if you want to use this function, you're going to have to give us a value, a variable. And this can be anything. It doesn't have to be a name. We can even give it 1. And we can say, print my person name, which is 1. So, and that seemed to have worked in the console. We can also print true. So when we print true, we have a true statement here. But here we have Oleg. So my second function, Oleg, we have person name, print person name. So it does print that to the console, and Calfioli. Then we have functions with multiple positional arguments. Definition, my third function, my first name, my second name, and phone number. So in this case, we don't just have one argument, but we actually have 3 arguments that are in order. So here we would print my first name, my second name, and the phone number. So we have 3 variables, and we assign each value, each argument to a variable. First we have the first name, which is Olaf, the second name, which is Calfioi, and then phone number 123, 123, 1234. And when we call our function, the interesting thing to note here is that the argument names, the declaration of the arguments, aren't the same values as the ones that we input. This is because Python doesn't actually check to see if this is the same value as what is required. It just looks at the position. So since first name is Olaf, second name is Calfioi, and then the phone number 123, 1234, then each value will go in order. First Olaf will go from first name to my first name, Calfioi would go from second name to my second name, and phone number would go from PN to phone number. And so when we run this statement, it should return Olaf, Calfioi, and then 123, 123, 1234, which is exactly what it does. But then we have keyword arguments. So this is the other type of argument that we can find within a function. So keyword arguments begin with the key is equal to value format. So here we have my regular function, which is name1, name2, name3. And rather than having just positional arguments in which our arguments go in order, we instead specify, okay, this argument is name 1, this argument is name 2, and this argument is name 3. So when we print it, we would still see Olaf wholly off Linux. But the great thing about using keyword arguments is that they don't have to be in order. Here I have definition my add function with num1 and num2 and return num1 plus num2. So I print my add function, num2 is equal to 25 and num1 is equal to 5. In this case, this argument would go into the second place here within my definition my add function, and num1 is equal to 5 would actually go here into num1. Even though I put num2 first, I specify this value to be equal to 25. Now it doesn't matter because we're using addition, but if we were doing subtraction, then this is definitely important, because using keywords rather than using positional arguments, you can see that we have a difference. This would be done positionally, in which num1 is equal to 25 and num2 is equal to 5. Here 25 minus 5 is 20, but instead we specify. So num2 is equal to 25 and num1 is equal to 5, and by using just keyword arguments, what we do is we change these argument values, and we have instead 5 minus 25, which is equal to negative 20. So now we can have both positional and keyword arguments, but first Python will check for positional arguments and then keyword arguments in that order. Definition, my mixed arguments function with first var, second var, and third var, it will print all the arguments. And so my mix args function 2, so first var would be equal to 2, and then third var is equal to 12, so 12 would be placed into the third var, and then my second var is equal to 3, so my second var would be 3. So when we print this function, we would get 2, 3, and 12. And then we have functions with default parameters. So I am not going to have, I'm not going to have to insert a value every single time whenever I declare my function, or maybe I'm going to have multiple values when I attempt to insert values into the arguments of this function. So I have definition, my regular function, my var1, my var2 is equal to 0.34, my var3, which is equal to 10, and then it prints out all those variables. So if I only have one argument, I can still run the function with this one variable, because as a positional argument, it'll be assigned to my var1. But if I wanted, for instance, to change the value of my var2 when I'm running the function, I can include 0.22, which would be a positional argument that would replace my var2 from 0.34 to 0.22. And the same can be done with the declaration here with the argument 1, 2, 3, 4, 5, 6 replacing 10. So you can see here that first we have 0.1 as my var1 with 0.34 and then 10, and then the same thing here except we place 0.22 with 0.34 and then 0.1, 0.22, and then 123,456. If we want to, we can also give a default value for my var1, and in this case we can also just run the function without having to apply any arguments, because each parameter here has a default value with which to work with. And then we have what's called recursive functions. So this is very similar to the while loop or for loop. Here you can see definition my recursive function x. We have a parameter of x, and this is a recursive function defined a factorial. If x is equal to 1, return 1. Otherwise, we return x times my recursive function with its parameter equal to x minus 1. So we are basically calling this function within our function. So when x is 5, if x is not equal to 1, so we don't return 1, else we return 5 times my recursive function of x minus 1, which is 4, which means my recursive function of 4 would have an argument value 4, 4 does not equal to 1, else 5 times 4 times my recursive function, which is equal to 4 minus 1, which makes it continue going on until x is equal to 1, in which case we return 1 times 2 times 3 times 4 times 5. So this should return 120. Printed. Oops. And the factorial of 5 is indeed 120. So you can also have a list as an argument. In fact, you can have any data type as an argument, but when looking at a list, you can see we have carp, bass, red snapper, we have all these different fish, and then we just use the fish list in here. And then we can basically say, okay, I want to iterate through this list from the parameter, from the argument of the function, and what will happen is it will print all the different kinds of fish. Carp, bass, red snapper, lebo, chanda, rufe. You can also use functions with dictionaries as an argument. So here I have fish, carp, bass, red snapper, all the fish that I want, each with its own key of 1, 2, 3. And so when I do for I in fish, it will return all the fish here within our dictionary. And then we can also do fish.items. And then this will return both the keys and their values. Or if I just want values, I can just say values. And this will return just the numbers 1, 2, 3, 4, 5, 6. Alright, you can also alter a list within a function. If you see we have a list here, 1, 2, 3, 4, 5, and then we delete the index of 2, which would be the value 3 within the list, and then we print the list. So here we have first our list, and then my list function list, and then we print the list. So here we have 1, 2, 3, 4, 5, and then we print the list after we delete the second function, 1, 2, 4, 5, and then we print the list again, and we have 1, 2, 4, 5. Next we have lambda functions. These functions can have as many arguments as you want, but they can never have more than one expression. So here you can see my lambda function is equal to this keyword lambda, which has the arguments of the function listed here, and then it has the statement within the function. So you can see the example here, definition my list function. Here the arguments are green, here the arguments are also green. Here's the definition. So this function doesn't have a name really, it's just a single function. So in here we print my lambda function of 10. 10 would be the value of my var, and it would return my var plus 10. So it should return a value of 20, which indeed it does. But we can put as many arguments as we want in here. Again, it should only have one expression. That's the point of a lambda function. Here we have my var1, my var2, and my var3. And in here we say, okay, I want my lambda function. I have the arguments of 4, which goes into my var1, 6, which goes into my var2, and 8, which goes into my var3. And what we should return is 4 times 6 times 8, which should be equal to 253, 192. And then we have the return value annotation. So this is optional. We don't actually need to include a return value annotation, but it is helpful, especially if others are going to be looking at your code and they're confused about what the return value is going to be. So in here, definition, my init function, after each argument, you can put a colon and then either int, string, or whatever type of data type you're expecting to receive within the myInt function. And then you can also, before the final colon, you can put a dash and then a greater than sign as like an arrow, and then you can also put whatever data type you would like to expect to return from this function. So here I return my value 1 times my value 2, and here I have a print function, my end function 1 to 2, which should return 2 as an integer, which it does. And then you can also do the same thing with a string type. So I have one string as my first value, string as my second value, and it should also return a string, and we would use string concatenation by just adding them together. And what happens now is we just have a bunch of asterisks. So what would happen if we tried to assign an integer value instead? Well, we would get a type error because this argument is expecting a string, but it got something else. As such, I'm going to put the asterisks back. And then finally, we can use a return value annotation with a list type if we know we're going to be changing a list, or we're going to be returning a list, sorry. Definition mylist function, we will return a list of strings, and then my list is 1, 2, 3, 4, 5, and then we return my list. And here we indeed return 1, 2, 3, 4, and 5. Alright, that has been functions. I hope you understood the topic, and thank you for watching the Python Basics tutorial.